All right, good morning and welcome to Master Talker online class. In today's video, we'll be talking about resistivity and conductivity. All right, resistivity is defined as the resistance per unit length per unit cross-sectional area. Resistance per unit length per unit cross-sectional area. All right, and it is measured in ohm meter. Resistivity is measured in ohm meter. Okay, but don't forget that resistance R is directly proportional to length and inversely proportional to area. Please note this, okay, that the resistance is directly proportional to length but inversely proportional to area. So if you remove proportionality sign, you will now bring in your resistivity role, resistivity L over A. So if I want to make resistivity subject of the formula, you now have that resistivity will now be what? Ra over what? L. Very, very important formula to note. Okay, that resistivity is what? RL over L. Okay, you should know that your R is measured in ohms and your area is measured in meter square. Then your length is measured in meter. So if meter cancel one of the meter, you see that I have that my resistivity is measured in what? Ohm meter. Ohm meter. All right, where my role is equal to what? Resistivity. Resistivity measured in what? In ohm meter. Okay, I now have that my R is what? My resistance. Resistance measured in ohm. I have that my A is equal to what? Area measured in meter square. And then finally, I have my L to be the length measured in meters. Okay, so now let's move to conductivity. Conductivity is simply the inverse of resistivity. In fact, I don't need to remember the formula for conductivity. Okay, I should just know that what? Conductivity is just simply the inverse of resistivity, and resistivity is the inverse of conductivity. So what do I mean by that? Let's use this delta to represent conductivity. Conductivity is simply 1 over resistivity. Very simple. So where this is your what? Where delta is your what? Conductivity. Conductivity. Okay, measured in what? 1 over ohm meter. Okay, that is per ohm per meter, or you say per ohm per meter. So that is that. And then this one is your what? Resistivity. Measured in what? Measured in ohm meter. Okay, so that is that. So you should know that what? The inverse of resistivity is conductivity, and the inverse of conductivity is resistivity. Okay, they are inverse of each other. So let us solve some calculation to illustrate that. The first question said the resistivity of a given wire of cross-sectional area 0.7 millimeter squared is 4.9 times 10 raised to power minus 4 ohm millimeter. Ohm millimeter. They now say calculate the resistance. Calculate the resistance of a 2 millimeter length. 2 millimeter length of the wire. Okay. Now, if you look at their own, they left everything in millimeter, so no need to convert. So I don't have any reason to convert since everybody is in millimeter. But if they are in different SI units, I have to make them to be in the same SI unit, or rather convert them to their normal unit, which is what? Which is in meters. Okay, so that is that. So since everybody is in millimeter, let's forge ahead. So solution, I have that my resistivity is equal to 4.9 times 10 raised to power what? Times 10 raised to power minus 4. Okay, and I have that my area is what? 0.7 millimeter squared. So I have that my length is equal to what? 2 millimeter. So if you remember that resistivity is simply what? Ra over L. Very simple. Ra over L. You now put everybody. So you are looking for what? Okay, they say I should look for my R. My R is unknown. So if I make R the subject of the formula, I'll have that what? Resistivity L over A, which is what? 4.9 times 10 raised to power minus 4 times my L is 2 divided by what? 0.7. So if you do the mathematics, you'll be having 0.0014 ohms. 0.0014 ohms. Okay, very simple question. We move to the next question. Question number 2 said calculate the resistivity of a wire of length 2 meter and cross sectional area of 0.004 cm squared, if the resistance is 5 ohms. Solution. Okay, so what do? The first thing they gave me is the length. The length is 2 meter, and then the area they gave me is 0.004 cm squared. So you need to convert it to meter by dividing by 100. So I have 0.004 divided by what? 100. But this thing is squared, so that my 100 should be squared. So what do I have? If I divide this, I'll be having 0.004 divided by 100 again. So I'll be having 0.1234564, okay, in meter squared. So what else did they give me? They gave me that the resistance is equal to 5 ohms. So I know that my resistivity is equal to what? Ra over L. Very simple formula. So I have what? 5 times what? 0.1234564 all over 2. So if you do that, you now have times 5 divided by 2. So I'll be having 0.123451. So if you count 1, 2, 3, 4, 5, 6. So I have 1.0 times 10 raised to the power minus 6 what? Ohm meter. Very simple. Okay. So number 3 question, the third question. Question number 3 said a given wire of resistance 10 ohm has a length of 5 meters and a cross sectional area of 4.0 times 10 raised to the power minus 3 meter. They now say calculate the conductivity. Very simple. Solution. I know that what? First of all, I know that my resistivity is simply what? Is simply Ra over L. So, and I know that conductivity is simply 1 over resistivity. So, which is what? Sorry, 1 over resistivity. So 1 over this means to turn it upside down. It should not be L over what? Ra. So that's the formula for conductivity. So my conductivity will now be my L, which is the length, is 5 all over the R, my resistance is 10 ohms, then times what? 4.0 times 10 raised to the power minus 3. All right. So if you do that, you're going to be getting 125 per ohm per meter. Okay, 125 per ohm per meter. So that is that for that. Or you just decide to calculate the resistivity. So after calculating the resistivity, you now say 1 over that resistivity. 1 divided by that your resistivity. You get your conductivity. It's not a difficult question. Question number 4 said calculate the length of constantan wire of diameter 0.6 millimeter and resistivity 1.0 times 10 raised to the power minus 6 ohm meter required to conduct a standard resistor of 35 ohms. Okay, solution. Now the first thing they gave us diameter, and the diameter they gave us is 0.6 millimeter, which is what? 0.6 divided by 1000, which is what? 0.1236. 123. Yes, in what? In meters. But I know that radius is what? Half of a diameter, which is what? 0.1236 divided by 2, which is what? 0.1233 in what? In meters. I know that my area is equal to what? Pi r squared, which is what? 3.142 times 0.0003 all squared. So my area will now be 3.142 times 0.1233 times 0.1233. So I'll be having 2.8278 times 10 raised power minus 7. Okay, so this is my area in meter square. So the next thing they gave me is my resistivity. My resistivity is what? 1.0 times 10 raised power minus 6 ohm meter. And the next thing they gave me is my resistance. My resistance is 35 ohms. Okay, I will tell them that my resistivity is what? Ra over L. So I'm looking for L. My L will now be Ra over my resistivity, which is what? My R is 35 times my A is 2.8785. Sorry, 8278 times 10 raised power minus 7. Now divided by my resistivity 1.0 times 10 raised power minus 6. So if you do everything, you are going to be having 9 meters. 9 meters. All right. So let's talk about electrical resistance and its measurement. 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 All right. All right. Resistance R is an opposition given to a flow of an electric current through a conductor. Okay. And the symbol is R measured in ohms, right? So factors affecting resistance of a conductor and the relationship between them. Okay, the factors that are affecting resistance, factors affecting resistance. Okay, the first factor that is affecting resistance is temperature. And resistance is directly proportional to temperature. So if the temperature of the wire increases, the resistance will increase. Okay. Number 2 is the length of the wire, the length of the conductor, or wire, the length of the conductor or wire. Okay, so is equally directly proportional to length. So the next thing is that what? The number 3 is resistivity. Resistivity. Okay, resistivity of the material or conductor of the conductor. So the resistance is directly proportional to resistivity as well. Resistance is directly proportional to resistivity. All right. So that is why we have that in general. Resistivity is directly proportional to what? To length. Okay, but it's inversely proportional to area. So we now have that R is equal to what? PL rho L over A. So that is how we now have that formula we have. Okay, so now write effect of rise in temperature on the resistance. Number 1, for metallic conductor, that is pure wire, the resistance increases as the temperature increases. That's why we say that it is directly proportional to that. So number 2, for semiconductor like silicon, germanium, etc., the resistance decreases as the temperature um, is increasing, okay, and hence their conductivity increases as an elevate as an elevated temperature. In other words, they have negative temperature coefficient of resistance. Okay, for alloys, the resistance is independent of the temperature. So for an alloy, the resistance is what? Independent of what? Temperature. Okay, so let's talk about the measurement of resistance. Resistance can be measured with the following. The first, very, very important, measurement of resistance. Measurement of resistance. Number one is what? The volt ammeter method. The voltmeter, the voltmeter ammeter method. All right. All right. This method is this method of measuring the resistance of a conductor is based on Ohm's law. Okay. In 1826, Simeon Ohms established a relationship between the current passing through a metallic conductor and the potential difference across the end or the terminal. Thus, Ohm's law stated that the current that passes through a metallic conductor is directly proportional to the potential difference across its end or terminal, provided that the temperature and other related physical factors remain constant. Okay, so in this one, we should remember our Ohm's law that said that what? That V is directly proportional to I. So therefore, V is equal to what? IR. So you now have that your R is now what? V over what? Over I. So when you plot a graph of V against I, you plot a graph of V in volts against I in this, we have a straight line graph, and then this is the slope. And the slope of potential difference with current is called the resistance. So this is change in V and this is change in I. So your resistance R is equal to what? Change in V over what? Change in I. Okay, which can be what? V2 minus V1 all over what? I2 minus I1. Okay, that's another formula for resistance. Very important formula to note. Okay, so the next one is the Wheatstone bridge. The Wheatstone bridge, number 2. The Wheatstone bridge. The Wheatstone bridge. Okay, I did not draw the other one. Please let me draw the other one before the Wheatstone bridge. So the diagram is like this. We have the ammeter here, okay, and then I have the resistor here connected to a voltmeter. Connected to a voltmeter. Connected to a voltmeter. All right. So I have my key. Then, and I have my circuit. This is what? The internal resistor. So this is the internal resistor. So that is the diagram for that one. Okay. So you can draw that in your book. This is my resistor R. So the next one, number 2. Number 2 said, number 2 way of measuring resistor is the what? The Wheatstone. The Wheatstone bridge method. The Wheatstone bridge. All right. Wheatstone bridge is an instrument used to obtain an accurate value of resistance. This consists of 4 resistors of resistance R1, R2, and R3 connected side by side together, okay, forming a closed circuit. The current flowing into the circuit divides into 2 branches. When current from the battery is passed into the circuit and one of the resistors is changed or varied until a stage is reached when no current flows into the galvanometer. Okay, Hmm. So for this particular one is this way. It's like this. We have something like this. We have something like this. I have a galvanometer here. The first resistor is here, R1. Okay, let me say that this is the first one. R1, R2, R3, and R4. Okay. Okay. So in this one that is like this, how do we calculate that? You should know that V is equal to IR. So V is equal to IR. We have that V is equal to IR. Don't forget this formula. Then my I is equal to what? My V is equal to IR. We want to get that. Okay. For this particular one, you should know that what? I1 over what? I2 is equal to R1 over what? R2. Okay. So in this type, we now have that what? That R1 over R2 is equal to R3 over R4. So this over this is equal to this over this. So that is how to get this one. This formula is very, very important and will help us in calculation. So let us just solve one calculation that is involving this. Okay, they will just draw something like that for you. They will just draw something like that for you. They say given that diagram, please, with the same diagram, they say find the value of the resistor R4 when the galvanometer shows no defection in the circuit, above. That one I drew before, please draw it again. Okay, given that R1 is equal to 30 ohms, comma, R2 is equal to 60 ohms, and then R3 is equal to 5 ohms. All right, you tell them solution. Tell them that R1 over what? R2 is equal to R3 over R4. Okay, so we're asked to find the fourth one. So if you put everybody now, you'll be having that 30 divided by 60 is equal to what? 5 divided by my R4. So if I cross multiply, I'll be having that my R4 is equal to what? 60 times 5, then divided by 30. So I will now have 10 ohms. Okay, I'll be having 10 ohms. So the next one, number 3, is the meter bridge. Number 3 ways of measuring resistance is the meter bridge. The meter bridge. Measurement of resistance using the meter bridge. Meter bridge is a bridge with low temperature, okay, when low temperature coefficient and length of 100 cm or 1 meter. The meter, they say it measures the resistance of a wire based on the principle of resistance. Okay, resistance R of a wire is directly proportional to the length, okay, of the wire. The resistance is directly proportional to the length of the wire. So you should know that for this particular one, I'm going to draw it. Please look at the diagram. You can draw it. This is the diagram. Okay, you can draw it, but this one is based on what? That the resistance R is directly proportional to what? To your L. So therefore R is equal to constant L. So my constant is equal to what? R over L. So which is what? R1 over L1 is equal to R2 over L2. So this is the formula for the meter, for the meter bridge. So they will tell you in the question that it is a meter bridge. So, and you know that the total length of the meter bridge is 100. Please note that the total length of the meter bridge is 100. So then I say, which in terms of x and r, okay, in terms of x and r, we have that what, x over L1 is equal to what, r over what, 100 minus L1. Okay, this is from the diagram. I will try to know how to draw this diagram. Problem. In fact, you should just know that the total length L1 plus L2 is equal to 100. So just know this. Forget about this formula. Just know that what? That the total, look at the two formula you need to note. Not this one. Just note this one now. And then you know that L1 plus L2 is equal to 100. Okay, 100 meter. These are the two things you need to know. So let us solve our question. The first question we have here, number one, said, when a known standard resistance of 2.0 ohm, okay, 2.0 ohm is connected to a is connected to the 0.0 cm end. Is connected to 0.0 cm end of a meter bridge. Okay, comma. Then I say the balance point is found to be at the 55.0 cm. Okay, then I say, what is the value of the unknown resistor. Okay, so solution, we have that what, that our R1, the known one, is what, 2 ohms. Okay, and then our L1, the length of that one, our L1 is what, 55.0 cm. They don't used to give your L2, so I'm looking for my R2, which is unknown, but I know that my L2 should be what, 100 minus that 55, because I know that if I add both of them, it should give me 100. So 100 minus 55 will give you 45 cm. So I will tell them that what, R1 over L1 is equal to R2 over L2. So if I make R2 subject, I'll have that R2 will now be what, R1 L2 over L1. So which is what, my R1 is 2 times my L2, 45, then divided by what, 55. So if you divide that, you'll be having 1.64 ohms. So this is the resistor of the unknown circuit. Okay, of the unknown. So the next question, question number 2. Question number 2 said, calculate the value of the unknown resistance X. They have already called it X in the meter bridge. They did not call it now R2, they called it X in the meter bridge circuit. Okay, in the meter bridge circuit shown below, if the galvanometer shows no defection when the length L1 is equal to 40 cm, Okay, so from what they drew here, I don't like drawing, but let me try. Problem, you know, they finish. They gave us the first resistor here as 20 ohms connected this way. Wow. Okay, and they have that the galvanometer. So this is where the balance point is. Say from here to here is my L1. So which means from here to here should be your L2. Okay. So I don't even need this diagram. This is the only thing I need. I'll tell them that my R1, let me solve here. I'll just tell them that my R1 is equal to 20 ohms. Okay. And then my L1 is equal to what? They gave me L1 as 40 meter. Okay, so 40 cm. So I know that my L2 will now be what? 100 minus 40, which is what? 60 cm. All right. I'm looking for my X. My X is unknown. I'll tell them that my R1 over L1 is equal to what? X instead of R2 over my L2. So my X will now be what? R1 L2 all over L1, which is what? 20 times what? My 60, then divided by 40. So what do you have? If you do that, you'll be having a 30. You'll be having 30 ohms. So 120 divided by 40 is 30 ohms. So question number 3. Question number 3 said in a meter bridge, experiment, comma, they say two resistor 2 and 3 2 ohms and 3 ohms, okay, occupy the left and the right gaps respectively. They now say find a balance point. Find a balance point from the left side of the bridge. Okay? Solution. Now this is a very simple question. You will just say that what? That our L1 is equal to, let's just call it L1. Then our L2 is always 100 minus L1. Okay? And I have that my R1 is equal to what? 2 ohms. And then my R2 is equal to 3 ohms. I'll tell them that my R1 over L1 is equal to R2 over L2. So let me put everybody. So my R1 is 2 over my L1 is still L1 is equal to my R2 is 3 over my L2 is 100 minus L1. So if I cross multiply, I'll be having cross multiply so that you have that 3L1 is equal to 2 in bracket of 100 minus what? Minus L1. So if you open bracket, you have that 3L1 is equal to what? 2 times this, 200 minus 2L1. So permit me to finish it up here. So collect items to have that 3L1 plus 2L1 is equal to what? 200. So 5L1 is equal to what? 200. So therefore L1 will now be what? 200 divided by 5. So what do you have? Have 40, right? 200 divided by 5. I have 40. So 40 cm. So the balance point from the left is what? 40 cm. So the balance point from the left is 40 cm. So that is that. So question number 4. Question number 4 gave us okay. Question number 4 gave us something like this problem. So that here is 8 ohms, and here is another 8 ohms. It's being connected to another 8 ohms. Then being connected to then now say that they have then the galvanometer is here. This is my G connected somewhere like this. Problem. Then I say that from here to here is 100 minus x, and then from here to here is my x. Then I say find the value of x. Okay, they say find the value of x. Now for me to find the value of x, we have to resolve this one that is in parallel. They say find the value of x. Okay, now for me to find the value of x, I have to resolve this one that is in parallel to be in series. So I'll tell them that what? Solution. So 1 over the one in parallel is equal to what? 1 over 8 plus another 1 over 8, because they are in parallel. So the R parallel, the short way I told you is what? 8 times 8 divided by what? 8 plus 8. So what do I have? So 8 times 8 is 64 divided by what? 16. So 64 divided by 16, 64 divided by 16. So I have 4. So this one is what? 4 ohms. So which means my R1 is now what? My 4 ohms. Then my R2 is now my what? My 8 ohms. The other one that is in series. Then my L1. My L1 is what? X. And then my L2 is what? 100 minus X. So if I still use my formula, I'll be having that what? My R1 over L1 is equal to R2 over L2. So put everybody have that what? 4 over X is equal to what? 8 over 100 minus X. So cross multiply to have 8x is equal to 4 into 100 minus what? X. So clear bracket, 8x is equal to what? 400 minus 4x. Collect items. 8x plus 4x is equal to what? 400. So 12x is equal to 400. So my x will now be what? 400 divided by what? 12. So my x is equal to what? 400 divided by 12. I have 33.3 meters. So that is that. So the next one we'll talk about is potentiometer. We can use potentiometer to measure it. Okay. Okay, no, potentiometer is not a measure of that, please. Is that? Okay, yes, the last one is potentiometer. Yes. The last one we can use in measuring resistance is what? Potentiometer. So potentiometer. All right. Potentiometer is a device for measuring potential difference. Okay. It consists of a uniform wire AB of total length 100 as well. Okay. Stretched on a wooden board by the side of the meter rule. Okay. Now the uses of potentiometer. Potentiometer is used in measurement of potential difference or the voltage using what? The potentiometer. Okay. They said this is based on the principle of V is directly proportional to L. Okay. That the potential difference is directly proportional to the length of the wire. So the wire is a uniform cross section. Okay. so that the resistance per unit length is constant. To show the R is directly proportional to L, or L is directly proportional to R. Okay, we now have that okay, in potentiometer. Okay, we say that for the first one, we have that it's what? For the measurement of what? The uses of potentiometer. The first one is what? For the measurement of a potential difference. And we should know that what? The potential difference is directly proportional to the length. So potential difference is what? KL. So my K will now be what? V over L. We now have that V1 over L1 is equal to V2 over L2. Another important formula to note. Okay, number 2 is comparing two low resistance using potentiometer. You can use potentiometer to compare two low resistance. Okay, you can use it to compare two low resistance. So, and how do we do that? So we have that the potential difference across AB is equal to this. In fact, this one is the same formula that we have the other one that said that my R1 over L1 is equal to my R2 over L2. Okay, that is for the second one. Then for the third one is your EMF. The third one is your EMF, and EMF is same thing as volts. So if you remember that the third one C, okay, this is B and C. So you have that your EMF. Okay, let me use capital letter E to represent my EMF. My EMF1 over what? L1 is equal to what? My EMF2 over L2, right? So that is that. So we're going to solve one calculation on that, and then we are good to go. Okay, we are going to solve two, then we are done. Okay, so the first question we are going to say said in comparing the EMF of two cells using a potentiometer, comma, a cell of EMF 1.2 volts gives a balance of length 90 cm. Then I say, what is the value of the EMF of another cell that gives a balance of 60 cm. Okay, solution. You have that your EMF 1 is equal to 1.2 volts, and the length 1 is what? 90 cm. So the EMF 2 is unknown, but the length 2 is 60 cm. We'll tell them a very simple formula that say that what? That your EMF 1 over L1 is equal to your EMF 2 over what? L2. So I'm looking for my EMF 2. My EMF2 will now be what? EMF1 times my L1, my L2, sorry, all over my L1. So if I do cross multiply, so you now have that what? 1.2 times 60 now divided by 90. So if you do that, you'll be having 0.8 volts. 0.8 volts. All right. Okay. So that is that. The second question, and which is the last question we are going to solve here, and then we are done for electricity. That is question number 2, said a balanced length of 48 cm is obtained when a cell of EMF 1.2 volts is connected to a potentiometer. Then I say what is the EMF of a cell which gives a balance length of 72 cm if the potentiometer wire is 1 meter long. If the potentiometer wire is 1 meter long. Okay, so we are not interested in the 1 meter long. We are interested in what they give at their balance point. So let this be your assignment. Forget the 1 meter and use your normal formula and get your answer. We are not interested in the length of the potentiometer. We're interested in the balance point. So thank you very much for watching. Please like, share, and subscribe.